This is Programming Chapter 3, Part 2. We're going to start off by modifying exercise 3.4. So let's go take a look at that. So we hard code 3 values for A, B, and C. We print the maximum of A, B, and C. So we print A, B, C, and we call the max function. The max function takes in 3 parameters, A, B, and C. These are copies of these A, B, and C. Remember that these are local variables. It checks to see if A is greater than or equal to B, and A is greater than or equal to C. So if that's the case, A is going to be the largest. If A is not the largest, then either B or C must be the largest. So we check to see if B is greater than or equal to C. If so, we return B. If none of these are true, then obviously C is going to be the largest, so we return C. Now, when we're doing our logic, it's very important to be aware of order. If we did this check first, we would get incorrect results because we would be returning B without checking A. So that's why this order is important. And we'll set a breakpoint. And we'll run this. Okay, it stops at the first one. We need to step over, and step into, because we want to see what the max function does. Step over. So it's going to check to see if A is largest. We can see that A is not the largest here. It's not the largest, so it skips, right? It skips executing this statement and jumps down to the next statement. Is B greater than or equal to C? Well, B is less than C. So it should not execute this statement and doesn't, and returns C is the largest. And that's correct. And we print this. Click on output to look at the output, and it hasn't flushed it. Okay, that's fine. We'll stop this, and then we'll just run this without a debugger, and we see that the max of 10, 8, and 15 is 15. To create a proper data set to test this function, we need to make sure that A is the biggest, C is the biggest, and add that to our test data set. So you need to modify this routine and create a minimum function. So we want to input some numbers, find the max, and then find the min. And in the comments section, please list out the sample test cases. Now, you've seen some extra code added to your files. And the reason is we include header files because libraries are very large and therefore use a lot of identifiers, and it slows down compiles. And sometimes we want to use identifiers that are in the libraries, so we need to only purposely bring in the desired libraries. And the reason why we might have duplicates is because we want to have slightly different functionality than the libraries. And we're going to cover the libraries that we're using in our programs. So in Java, we don't need any libraries to print, but we do need a library to get input. And that's why we do import Java Utils Scanner. And this is strictly for console input. We'll get into different types of input later. And for Objective-C, we need to include this header file. And it's for printing and for input. And for C++, there's 2 choices of libraries. And printf is from the original C, and cout is for C++. However, I like to use printf because it gives more control over how the output looks. And it's also thread safe. You're not doing multitasking now, but at some point you might want to do multitasking. And one of the reasons why I like printf is because it's easier to read the format and precisely control what kind of formatting you want done on the output. It's a little bit more complicated using cout. So if you're using C, you need to include these headers. If you're using C++, you need these headers. And if you use a lot of logic, it's good to have a flowchart to diagram your logic because it's easier to follow than code. So for a simple if statement, we check to see if the age is greater than 65. If it's true, we execute this statement. If it's no, we just fall through to the next step. And then after it prints senior, it goes to the next step. And then this is a stop, or it could continue doing more code. For the if-else, here we check to see if the number is odd. If it's true, then we jump down to print odd, and then we go to the next step. If it's not odd, we print even, and then it goes to the next step. And again, we can add more code down here. And this completes Chapter 3, Part 2.